Okay, here's another problem from my try-it slides from class. So this one is also more straightforward because we don't have complex naming. We can use common names. So let's take a look at it. So here I can see that my longest carbon chain is going to be through this path of the compound. I do see that the double bond is a substituent. It is not part of the parent chain, even though it's bonded to it. It's not included. So I'm not going to look at that to try to figure out my numbering. Instead, I want to look at my substituents. So if I number from left to right, I'll have this is my numbering. And if I go from right to left, I will have 1, 2, 3, 4, 5, 6, 7. Okay. So if I look from left to right, 3 is the first number I hit. From the other direction, 3 is also the first number I hit. And then I don't have a tiebreaker because I still get 4 and 4. Okay, so numbering this isn't helping me. If that fails, I need to go with alphabetical order. So I have from left to right, so I'm going to match the colors. I have a 3-methyl group here versus on the right to left, this would be a 3-methylene. Okay. So those are the names of the substituents. Alphabetizing is going to have to tell me, well, I don't have a difference until I get to the ene part. So this tells me 3-methyl is going to win. Why is that going to win? Well, it's shorter of a name. If you think about the idea of if you have the name Matt versus Matthew, which one would you say comes first alphabetically? Hopefully you say Matt, all right? Because when it's shorter, it comes first alphabetically. We've all sat through a long graduation service that tells us that. All right, anyway, so if the methyl is what takes priority here because of alphabetizing, that means that's going to tell me what my numbering is going to be. So I need to get rid of the numbering from right to left because now I want to make sure that methyl has the lowest possible numbering. So instead of 3-methylene, I now have a 5-methylene here. And then I have my 4-methyl group as well. And now I've named all of my substituents. Real fast, we'll talk about why this is methylene. So if you look, there's a carbon here that has 2 hydrogens. Ooh, okay, carbon with 2 hydrogens. And we know the name for a carbon with 2 hydrogens is going to be methylene. So it just so happens that this substituent has a common name that matches the definition of that. So that's why we name it that. So now we're going to put it all together into the whole entire name. So I have 2 methyl groups. So I have 3,4-dimethyl, 5-methylene. And then here, again, the double bond is not part of the parent chain. It's just bonded to it. So I'm going to have heptane as my parent name. All right. Hope that was helpful.